Stoichiometry. In stoichiometry, we must know how to balance how to write chemical formula and how to balance chemical equations. How to write chemical formula? We must know that in chemical formula, we have to know group and valency. Group 1, valence 1, 2, 2, 3, 3, 4, 4, 5, 3, 6, 2, 7, 1. After that, this was positive and this was negative because 1 and 2 and 3 losing electrons. So it will be valency positive, positive 1, positive 2, positive 3. Starting from 5 to be negative 3, negative 2, negative 1, 4 accepted to be positive or negative. In case of transition metals, you will find that they have more than one valency, but all of them have common 2, valency 2, except silver 1. And if we have any number other than 2, you will find it written I, double I, triple I, IV, V, VI, and V double I. This means that 1, 2, 3, 4, 5, 6, 7. And if you haven't any number beside, it will be 2. Like iron oxide. It means that iron, Fe is 2, oxygen group 6 valence 2, so the formula will be FeO. Iron 3 oxide. So the valency here is 3. So Fe is 3, oxygen is 2, it will be the formula Fe2O3. Also, if you have copper oxide, for copper oxide and copper 1 oxide. For copper oxide, Cu is 2, oxygen 2, so it will be CuO. While copper 1 oxide, Cu is 1, oxygen is 2, the formula will be Cu2O. After that, we said for radicals or polyatomic ions, for radicals or polyatomic ions, you must know that for valency 1, we have OH negative, hydroxide, nitrate, nitrite, and ammonium. For valency 2, we have carbonate and sulfate. For valency 3, we have phosphate. So this is hydroxide, nitrate, nitrite, ammonium. And you have a difference between ammonium and ammonia. Ammonium, NH4 positive, ammonia, NH3. Carbonate, and then sulfate, valence 2, phosphate, valence 3. After that, we have a difference between 8, ite, and ite. For the difference between 8, ite, and ite, in case of sulfur and nitrogen. For sulfur, sulfate means highest number of O. It will be SO4. Ite reduce O. SO3. Ite without O. It will be S. Nitrate NO3. So nitrite NO2. Nitrite N. Like, for example, if you need to write the formula of magnesium, nitrate, magnesium, nitrite, magnesium, nitrite. So it will be for magnesium nitrate, MgNO3 by 2. Magnesium nitrite, it will be MgNO2 by 2. For magnesium nitride, it will be Mg3N2. Why Mg is 3 and 2? Because Mg is 2, N is 3, cross, it will be Mg3N2. This is magnesium nitrate, magnesium nitrite, magnesium nitrite. After that, how to balance chemical equations. For example, if you have C2H5OH plus O2 gives CO2 plus H2O. CaNO3 by 2 gives CaO plus NO2 plus O2. Fe2O3 plus CO gives Fe plus CO2. What I want you to know, for example, if you have 2CaNO3 by 2, if I'm asking you the number of atoms in this molecule, you will find that for Ca we have 2Ca. This is common factor for all. And for N, this is common factor for O and N, while 2 is common factor for all. So we have 4N, 2 multiplied by 2. So 4N. And for oxygen, we have 2 multiplied 3 multiplied by 2, it will be 12. So it will be 12O. For the number of atoms in Ca, we have 2, 2 multiply Ca. For number of atoms in N, we have 2, this common factor inside brackets, multiplied by 2, it will be 4. Number of atoms in oxygen, 3 multiplied by 2, multiplied by 2, it will be 12. After that, the total number of atoms in reactant equal total number of atoms in product. And then we must start with the elements that not be repeated, like oxygen now repeated, oxygen, 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 oxygen to be repeated, this to be the last. So C2, so we must have 2. After that, we have 6 hydrogen to be 3. So we make balance from left to right. After that, from right to left. For carbon 2, we made 2. For hydrogen 6, we have 6. After that, we have here 3 oxygen, and we have here 4 oxygen to be 7. So we have 1 to be 6, so 3. Again, 2 carbons, 2 carbons. 6 hydrogen, 6 hydrogen, 3 multiplied by 2. After that, we have 3O and 4O to be 7O. This is 1, remaining 6. 3 multiplied by 2. This is number 1. Number 2, Ca. N is 2. I make 2. O is 6. 4, 6, 7. If you have odd and even, so you must make multiplied by 2. So 2Ca, it will be 2. N is 4. 2 multiplied by 2, it will be 4. After that, for oxygen, we have 12. 2 multiplied 3 multiplied 2, 12. We have 8 plus 2, 10 plus 2, 12. Fe is 2. We will make 2. Carbon 1 is 1. Oxygen 4, we have 2. We will make 2. But now we have 2 carbon and 1 carbon. So we will add 1 to be 3. 3 carbon, it will be 3 carbon. 6 oxygen, 3 plus 3, 3 multiplied by 2. These 4 balancing equation. After that, for calculations, how to calculate number of moles. For number of moles, you must know that number of moles equal mass over molar mass. This in case of solid. volume decimeter cubed over 24. This is for gas at RTP, room temperature and pressure, equal volume centimeter cubed over 24,000, equal concentration multiplied by volume decimeter cubed in case of liquid, equal number of particles, number of molecules or atoms or ions over Avogadro's number, 6 times 10 power 23. So this is the number of moles. How can we know that? Can I use mass over molar mass or volume over 24 or concentration multiplied volume or particles over Avogadro's? This is Avogadro's constant or Avogadro's number. How can we know? For the units of mass, you will find it gram, kilogram, or ton. So this is mass. For volume, you will find centimeter cubed, milliliter, decimeter cubed. And then if we have centimeter cubed equal milliliter over 1000 to be decimeter cubed. For concentration, you'll find it mole per decimeter cubed or mole multiplied decimeter power -3. These are the units. So for example, if I have calculate number of moles for each of the following. Number 1, 46 gram of sodium atom. Number 2, 500 centimeter cubed of 2 mole decimeter power -3 of HCl. .48 decimeter cubed of oxygen gas at RTP. In each case, here, number of moles is equal to mass over molar mass. So it is equal to sodium from periodic table, you'll find it 23. This is the molar mass. And then we have 46, this is the mass, equal 2 moles. For second one, concentration and volume. So number of moles is equal concentration multiply volume decimeter cubed is equal to 500 over 1000 to change from centimeter cubed into decimeter cubed multiplied by 2 to be 1 mole. Number of moles in case of gas at RTP, volume decimeter cubed over 24. If we have by centimeter cubed, we will make over 24,000 equal 48 over 24 is equal to 2 moles. This is for number 1. Number 2, if we have number of moles and then we need to obtain mass, volume multiplied by molar mass to get the mass, multiplied by 24 to get volume decimeter cubed at RTP, over concentration to get volume decimeter cubed, over volume decimeter cube to get concentration. This we made now cross multiplication. After that, if we have more ratios, for example, C2H5OH plus 3O2 gives 2CO2 plus 3H2O. After that, we have 23 gram of ethanol, and then we need volume at RTP. We need concentration. If we have 500 centimeter cubed, we need to calculate mass. We have three steps. Number one, to get number of moles. You must have any given, and then to get number of moles. We have now mass, so we'll get number of moles of C2H5OH is equal to 23 is a mass over molar mass 46. You calculated molar mass is equal to 46. 12 times 2 plus 1 times 5 plus 16 plus 1 is equal to 0.5 mole. This is number one. Number two, more ratio. How we get more ratios? This is a coefficient from the equations. Now we have number of moles, 1 mole. This is the number of moles, coefficient, the balancing equation. Reacting with 3, reacting with 2, reacting with 3. After that, we calculate the new one to be 0.5. So 0.5 will produce cross multiplication to be 1.5. 1 gives 3, 0.5 gives 1.5. 1 gives 2, 0.5 gives 1. 1 gives 3, 0.5 gives 1.5. This is number 2. Number 3, you have now number of moles. After that, number of moles multiplied by 24 to get volume at RTP. Number of moles over volume to get concentration, but we make it over 1,000. Number of moles multiply molar mass of H2O, so multiplied by 80. After that, empirical and molecular formula. How we calculate empirical and molecular? For example, if you have carbon and hydrogen, and then we have the masses 24 and 4, and then we need to calculate empirical formula. For empirical formula, we will write AR, number of moles, and then ratios, and then formula. For AR from periodic table, this 12 and this 1. Number of moles will make division, 24 over 12 will be 2, and then 4. More ratios make division for the lowest value over 2 to be 1 to 2. 1 means 1 carbon and 2 means 2 hydrogens, so the formula will be CH2. In case of 1 to 1.5, we'll make it by 2, like to be 2 to 3, like Al2O3. This is the empirical formula. After that, for the molecular formula, if we have the molecular mass equals 70, then calculate molecular formula. Molecular formula equal molecular mass over empirical mass. This 12 plus 1 times 2 is equal to 14. So 70 over 14 is equal to 5. 5 multiplied by CH2 is equal to C5H10. So this is the molecular now. And then the molecular, if you simplify the molecular, it change into empirical. After that, in case of, if you have container, and then we have mass of container to be empty container, and then mass of magnesium plus container, then mass of magnesium oxide plus container. After that, calculate the empirical formula. At the beginning, mass of magnesium plus container, we will make minus mass of container to get magnesium. This is number one. Number two, mass of magnesium oxide plus container minus mass of container to get magnesium oxide. This is number two. Number three, magnesium oxide minus magnesium to get oxygen. After that, we'll make the ratio magnesium and oxygen. For the percentage, we have percentage of element in a compound, percentage yield, and limited and excess. For the percentage element in a compound, like for example, if you have C2H5OH equal 46 gram, percentage of carbon, percentage of hydrogen, percentage of oxygen is equal to over 46 multiplied by 100 over 46 multiplied by 100 over 46 multiplied by 100. Then number of carbons, you have two carbons, 2 multiplied by 12. We have 6 hydrogen multiplied by 1. We have 1 oxygen multiplied by 16. This is percentage of element in a compound. For the other percentage, percentage yield. For percentage yield, we said that is equal to actual over theoretical multiplied by 100. The actual one, this means the given that we have. Theoretical, this calculated multiplied by 100. For example, if we have N2 plus 3H2 gives 2NH3, and then we have 14 grams and then 15 grams. Calculate the percentage yield. For the given, the actual, 15 is actual. For theoretical, to make it consider as X, is theoretical. So we'll make 1 moles gives 2 moles. After that, 14 over 28 is equal to 0.5. 0.5 moles, mass over molar mass. So 0.5 moles gives to be equal 1 mole. Then mass is equal to number of moles multiplied by molar mass is equal to 1 mole multiplied by molar mass 17. NH3 is equal to 17. So it will be 15, this equals 17, over 17 multiplied by 100. And actual must be lower than theoretical. Actual less than theoretical. For limited and excess, how can we know this is limited or excess? We'll make like that. For example, if you have N2 plus 3H2 gives 2NH3. If we have 14 and then gives 15, calculate limited and excess. If the number being to be 17 or the number to be 14, if you have the number that will be calculated is greater than given, this is now limited. If you have the number calculated is lower than given, this is now excess. So this means that if the actual, this one given, this is the actual. This calculated, this theoretical. So if actual is less than theoretical, this means that this is limited. If the actual is greater than theoretical, this means that this is excess.